All right, here we go. We're going to start with a video. So when we talk pollution, when we talk air pollution specifically, we worry about carbon dioxide. Carbon dioxide is the pollutant that the world has gotten behind and said, let's make a difference with climate change by limiting your carbon dioxide output. It is in no means the worst of our climate change gases. What it is the one that's easiest for you to make a change in your lifestyle and have an effect on climate change. When we look at coronavirus, what's been going on in China right now, they have reduced their carbon dioxide emissions by 30% because everyone is quarantined, because manufacturing is shut down. So it shows that we could make a change and reduce carbon dioxide emissions. Again, not the worst of our climate change gases, but the one that we can influence our behavior to reduce. This is a satellite image of the carbon dioxide over a year, and you're going to see how it changes in the northern and southern atmosphere. Oops. September, when we had that first lecture, and we talked about the difference between East Germany and West Germany. Anyone remember the kind of cool thing that East Germany would do? A long time ago. East Germany, during their peak growing time, would reduce manufacturing, would kind of reduce how much factory work is going on. They did it for two reasons. First reason is the workers could then go out and work on the farm. But the second reason is they knew, this could be a problem. It means I just got kicked off the internet. They knew that, sorry, slight pause. And my mouse is gone. It's the end of world, people. Okay, there we go. Back to what I was saying. This is going to be great in the podcast. East Germany knew that there were chemicals that were being released by their factories that harmed the plants that were growing. And so they reduced the factory use during the growing seasons. Now, we've gotten really good about filtering out those pollutants out of our emissions from our factories, but would it be beneficial to limit some of our factories? What season should I limit the factory use? Summer or winter? Some of y'all say summer. Anyone say winter? When is our carbon dioxide the highest in the northern hemisphere? It's highest in the winter because we don't have plants to act as a carbon sink. And so if we could mediate and kind of balance that out a little bit by limiting our factory use in the winter, when we don't have that carbon sink, and then ramping up in the summer when we do, maybe we can help things a little bit with climate change. Okay, primary pollutant. Again, we talked about this in our last lecture. A primary pollutant, something that is deadly in the form that it comes out in. Our primary pollutants are coming out of our smokestacks for our factories. They're coming out of the tailpipe of your car or from a natural emission source. Our main primary pollutants when we talk atmospheric pollution are carbon monoxide. Carbon monoxide is deadly because it binds to your hemoglobin in the same spot that oxygen does. So when carbon monoxide is present, it competes on the hemoglobin for binding sites with oxygen. If the carbon monoxide wins, you essentially suffocate even though you're breathing. We see carbon monoxide poisoning in people that use gas heaters that aren't well kept up because carbon monoxide is released. You guys talk about Sylvia Plath, right? In English. She was a poet, stuck her head in an oven. We see some carbon monoxide in times of like blizzards or natural disaster, and people are trying to heat their house and they think, I know, I'll turn on the oven and leave the door open. Ovens that are not well maintained or that are older will release carbon monoxide, and if you leave that oven open, now it's in your house and you can die of that. It's the same reason why they don't want you barbecuing inside, is because barbecues release carbon monoxide. And if you're in a closed space like inside your house, You're going to be exposed to it and possibly not good. Carbon dioxide, NOx, SOx, those are main of our gases. And then suspended particulate matter. Particulate matter is abbreviated PM. That is all of the stuff that's suspended in the air. If you ever look at a window with light coming through and you see all the stuff kind of in that stream of light, all of that's particulate matter. So dust and ash and skin cells, all of that's particulate matter. When we measure air quality, it's measuring the amount of particulate matter in the air. A secondary pollutant has to undergo some chemical change to be deadly, and so our SOx mix with water in the atmosphere and create acid rain. Our oxygen mixes with UV radiation and creates ozone. These are things that undergo chemical change to become problems. We have natural sources of air pollution. It is not just man. Guys, every year on every test, AP or IB, they're going to try and trick you into admitting fault for all of the world's evils. There is always a question like, extinction is caused by man. True or false? Not all extinction. Good amount of extinction, but not all. Air pollution is primarily caused by man. True or false? False. We cause some, but not all. Our natural sources of air pollution, volcanoes. Volcanoes release a lot of gases. They also release a lot of particulate matter in the form of ash. In the 80s, the Philippine volcano erupted and dropped the temperature of the planet 1 full degree because the particulate matter kind of filtered out all of the solar radiation that was coming in. We had ice on the Thames River in England, and that doesn't ever happen. So we know that volcanoes release a lot. If you've ever been in a lightning storm and there's been a strike nearby and there's that smell is the NOx. It's created by the lightning, the actual lightning bolt hitting. Forest fires release particulate matter, carbon monoxide, NOx, carbon dioxide. All of those plants are carbon sinks. You burn them, all of that carbon's released back up into the atmosphere. In addition, you have all of the ash that becomes a particulate matter. Plants release something called VOCs. Guys, a VOC is a volatile organic compound. It's mentioned somewhere else in the slideshow, but let me just put it out there. VOC, volatile organic compound. Anytime that you smell a plant, that's a volatile organic compound. So anything that has an odor or a scent is a VOC. We like some of those VOCs, we don't like others. All along the medians on La Paz, they have flowering garlic planted. It's a pretty plant, pretty purple flower. Smells like a dead skunk. That smell is VOC. We know that 30% of sulfur oxides are coming from natural sources. 44% of nitrogen oxides are coming from natural sources, and 89% of VOCs. There's a lot of smelly stuff coming in nature. Things have scent to attract pollinators. They also have scent to repel predators. If you had earth science in high school, you have a slight leg up because there is a section of earth science on the APES test. Not on the IB version, but on the AP version. Right after we're done with pollution at the end of March, I'm going to give you a review packet to kind of review some of this earth science. So plate tectonics, that kind of thing. This is the other piece of earth science that you probably got in 8th grade and then maybe haven't seen again since then. I saw on last year's IB test, they gave you this graph and they asked you to put a line where the troposphere was and a line where the stratosphere was. So you had to know that. So troposphere is ground to about 20 kilometers. Troposphere is what your head's in right now. Stratosphere goes from about 20 to 60. Stratosphere is where we worry about air pollution. Troposphere has the pollution that is kind of the stuff you see, the smog. Stratosphere has weather and some of the better things, except ozone is good there, and if we get rid of ozone, it's bad. If we have ozone in the troposphere, it's bad. Just know this graph. This is a memorization thing. Memorize this graph. If you're a climate denier or you know one, this is where they get their evidence. They say, look, the Earth has warmed and cooled 5 times in Earth's history. This is a cyclical pattern. There is nothing to worry about. By the way, we're still coming out of an ice age. All of that's true, and we know it's true because we pull ice cores from Antarctica and we look at the amount of carbon dioxide in those ice cores. We pull ice cores and we look at the pollen, and based on the pollen, we can estimate what the temperature of the planet was. If there's a lot of pollen in that ice core, in that layer, then it must have been a warm time period. If there's no pollen, it must have been an ice age. We can look at the fossil record. We know that in 5 layers of the fossil record, as you descend in the Grand Canyon, there are marine organisms, which means the oceans 5 times went all the way to the Grand Canyon, which means the ice caps had melted 5 times. The whalebone on my counter came from when they excavated for the 300 building, which means this was ocean. All of that's true. The difference between what has happened in the past and what is happening now is we are coming out of the ice age faster than we ever have before. This speed, this acceleration of temperature change is bad for the animals. When we had the other 5 events, we had time for evolution to catch up. Animals were able to adapt. Things were able to fill niches because evolution is a slow process. Right now, as we accelerate this, animals can't evolve to keep pace with the changes. And so we see more extinctions because of that. Ozone was an issue. It's not necessarily an issue so much anymore, but we got to learn about it. Ozone occurs in 2 layers of your atmosphere. It occurs in the stratosphere. That's where it belongs. Ozone in the stratosphere is a good thing. Ozone prevents or blocks UV radiation. UV radiation is what gives you sunburns. UV radiation is what gives you skin cancer or cataracts. So we want ozone in the stratosphere. Where we don't want it is in the troposphere. Ozone in the troposphere, in the layer that your head is in, causes smog, which is an LA term, by the way. It's a combination of air pollution and fog that leaves that brown haze out. So if you're ever kind of up high and you look out towards the city and it's kind of brownish, that's smog. That is ozone in the troposphere. We want it in the stratosphere. We don't want it in the troposphere. Last year, AP did something very, very mean. And I didn't think they'd ever do it, so we didn't focus on it a lot. AP asked you to identify the proper equations for ozone. And it gave you 5 different equations. And you had, Grace is back there going, yeah, I hated that question. Yeah. So make sure you memorize the different equations for ozone. The good news is if it appeared last year's test, the odds of it appearing on this year's test aren't great. But memorize it nonetheless, because that was a sucky question that I'm afraid you're going to get. Because of that question, I'm actually going to show you the video. Please pay attention to the video. It talks about how ozone's formed, where it's good, where it's bad, and why. In the 50s, we started seeing that maybe there was going to be a problem. Maybe this ozone in the stratosphere, where it belongs, was getting thinner than it should. In the 70s, the late 70s, early 80s, we went, whoa, we got issues. There is a hole in the ozone, like a literal hole in the ozone layer over the North and South Pole. Not great for Australia, right? Especially since Australia is the land of blondes, and this causes skin cancer, which blondes are most prone to. In the 80s, it was also the time of big hair bands and big hair in general. The higher your bangs, the closer to God, right? You all can't go to the bathrooms now because of vaping. In the 80s, you couldn't go to the bathroom because of hairspray. We had Aquanet, which was like the cheap version of Hairspray, and we had butane portable curling irons, and we would go into the bathroom during passing period, and the goal, this is so embarrassing, the goal was to get your bangs to do this. And so you'd go out with your curling iron and straighten it and then spray it so that it would be like straight up. I'm so glad I don't have my childhood photo albums. And I'm so glad I grew up before Facebook. Straight up, I kid you not. We were polluting the environment one can of Aquanet at a time. And it was the time of like Whitesnake and Guns N' Roses, and they had these long, luscious locks that they shellacked into place. We figured out that the propellant in Hairspray, the chlorofluorocarbons, that was breaking down ozone when we released it into the atmosphere. Not great. This was the first time, guys, that we had PSAs, public service announcements, that made a change in the environmental movement. And it was bands like Whitesnake and bands like Guns N' Roses that got on MTV because, shocker here, MTV played music videos. That's all they played. It wasn't until like my senior year in high school we got Beavis and Butthead. Don't go back and Google Beavis and Butthead. It wasn't good. We thought it was at the time. But we got Beavis and Butthead, and it was like the first like scripted thing on MTV. Before that, it was all music, 24 hours a day. Headbangers Ball. You'd go like in your room after school, and you'd listen to Headbangers Ball, and you'd headbang. But they got on MTV, and they said, maybe we don't need big hair anymore. Maybe we don't need hairspray. Maybe we're damaging the environment. And we made a change. We're behind the movement of getting chlorofluorocarbons banned and out of hairspray. Just out of curiosity, anyone know what music movement followed the big hair bans? Nirvana come to mind? No, it was grunge. So now we went from like shellacking our hair and making it perfect to not washing our hair for like days on time and wearing flannels and army boots. A little extreme of an environmental movement, but I'll take it. Nirvana, best band in the history. Ozone layer is not a problem anymore. So we mentioned it. You need to know the history of it in the stratosphere, but it's not something that your generation needs to worry about. My generation solved the problem. The main sources were those chlorofluorocarbons that were in accelerants. So they were in your hairspray, they were in your deodorant, anything that you essentially sprayed had chlorofluorocarbons, and it's what propelled it, what sprayed it. We changed that to hydrochlorofluorins. They're still not great for the environment, but the CFCs lasted a long time. They didn't break down. They were persistent in the environment. The HCFCs break down very quickly, which means you can use your spray deodorant, hopefully not for a viral challenge, that's bad, but you can still use your spray deodorant and that propellant will break down within minutes of being released. The other place we still see CFCs, they still exist, is in your air conditioners. So your air conditioner of your car, air conditioner of your house, and in your refrigerator. Those are closed systems, which means that chemical is never escaping out into the atmosphere. You never have to refill that in your car. So we fixed the problem. Halons are a problem, but we can't get rid of our fire extinguishers. We don't use them that often. It's all good. And a couple other places. Here's the timeline. In the 1990s, MEDCs eliminated CFCs. So that movement, MTV, we got rid of the big hair. And by the 2000s, LEDCs started working on it and eliminated it by 2010. 2006, there was an anomaly. So the data showed a huge ozone hole. It only lasted the 1 year. We think it was due to natural events that put gases out into the atmosphere. All right, stratospheric ozone. We want it. We freaked out when the hole developed. Tropospheric atmosphere is bad. Tropospheric atmosphere is air pollution. It's created by a combination of the inefficient burning of fuel with hot, warm weather. Guess what is the epicenter for the inefficient burning of fuel and hot, warm weather? Los Angeles. Because we are a car culture that lives where it is hot and warm. And so really LA was the first place to put a name to it and investigate it. Again, it's that brown fog that you see when you look out among the hills. The primary issue with it, other than human problems, right? It causes lung problems and eye irritation, is that it damages chlorophyll. What do we need chlorophyll for? What process? Photosynthesis. Without photosynthesis, do we exist? No. UV radiation. Why we need it in the stratosphere. We talked about all of that. Cancer, damage to organisms. Not great. Hold on. I feel like I'm missing something. No, I guess not. Okay. Urban air pollution. 1 billion people are exposed to outdoor air pollution and 1 million die prematurely because of it. That's usually a respiratory problem. So increases in asthma. We know that if you live within 2 miles of a major freeway, you have a greater risk of asthma. Famous IA is done every year, I told you guys, which compares our cross-country team to Trabuco's, or our track team to Trabuco's. Why? Our track team practices essentially on the freeway, whereas Trabuco's nice and far from it. Primary air pollutants are carbon monoxide, carbon dioxide, and unburned hydrocarbons. So any of the gases coming out of your tailpipe. And I'm going to show you the air pollution video. Got issues. I'm not going to take the time to show the video. China's gotten a lot better in the last 2 months because we're locking people down. First time we had a Clean Air Act was 1970. It identified 6 major air pollutants and put kind of regulations on it, on the cap of how much you can pollute. This was mostly for companies, for manufacturing. Remember, though, the downside to this is there are limits. You can buy pollution credits from companies that aren't polluting that much. So yes, it helped. It didn't completely solve the problem. Our main air pollutants, sulfur oxides. Most of it is coming from combustion, so from burning fossil fuels, but some of it is natural. It leads to acid rain. We have fixed the acid rain problem in our country. So it's from manufacturing. When you look at big factories or you drive into LA, some of these buildings have big smokestacks on them, the big pillars that come out of the top of the factory. The smokestack is to move the pollutant out of the troposphere, essentially. You're pushing it as high up into the atmosphere as you can. That didn't solve the sulfur oxide problem. What did is technology. In those smokestacks, we put in scrubbers that pulled the sulfate out of the gas. So out of what's being released in that smokestack. You're basically scrubbing it free. You're putting it into a water solution before it gets into the atmosphere. When it gets into the atmosphere, it naturally binds with water vapor and creates acid rain, which then starts melting stuff. We have solved this problem. Let me just reiterate that. The scrubbers in the smokestacks have solved the problem. Nitrogen oxides are a colorless, odorless gas. Comes from the burning of fossil fuels, comes from some natural sources. Nitrogen dioxide's kind of reddish brown. When we look at our smog, when we look out there, it's a brown haze. It's a combination of ozone in the troposphere and nitrogen dioxide. Both of those are coming from your tailpipe. Talked about carbon monoxide already. We know about carbon dioxide. Realize that carbon dioxide is not one of the 6 that's regulated. Where we see regulations on carbon dioxide is in legislation as far as agreements to decrease the amount of carbon dioxide. It's not a law. It's an agreement. It's not something the EPA monitors. Particulate matter is anything solid that's floating around. It's skin cells, it's dust, it's ash. Spit. Ew. Right? Causes lung problems. Next week, we're going to run a lab where you figure out which classroom that you're in has the highest amount of particulate matter. It's kind of fun. Okay, photochemical smog. This is what we deal with in Southern California. It is a combination of hot days and lots of vehicles. It is also due to our inversion layer, which means we're surrounded by mountains, and so our air and our smog get trapped in the troposphere. This is the worst in the early mornings and the early evening. Why? Rush hour. It's when people are traveling. Why is it worse in the evening than in the morning?
Because the earth is already hot.
Yeah, the temperature of the day. Please pay attention to this video. It explains photochemical smog. Often a test question.
On July 26th.
Know it. Live it. Inversion is where we have this trapping of the air because of our geography. LA is surrounded by mountains, and so the pollution doesn't get to escape out, and it just kind of builds and builds and builds. Lead is a major air pollutant. Lead causes neurological problems, lead poisoning. In the early times, we realized that if we add lead to gasoline, your cars work better. The downside is lead's not good for you. And so in the 1970s, we started phasing lead out, which is why when you go to the pumps, you buy unleaded gas. That's where that stems from. Realize if your house is older than 1975, you could have lead in your paint, and if you start chewing on that or licking the walls with old paint, you're going to get lead poisoning, so don't lick things. Volatile organic compounds, VOCs, are things that give off a strong odor. Where we see it the most, if you guys ever had your room painted or your house and that smell and it gives you a headache, that's the VOCs. And now you can buy paint that are low VOC or no VOC. Acid rain is a problem that we solved. So the atmospheric pollutants mix with atmospheric water, where it then falls down. And the problem with acid rain is that it kills chlorophyll, kills our symbiotic root bacteria, so we don't have that ability to get nitrogen out of the atmosphere. Makes our lakes acidic, and a lot of animals can't live in acidic water. And it leaches nutrients from the soil, so it affects our agriculture. Again, not a problem in the U.S. anymore. If you ever go somewhere where it was a problem and you look at the old limestone statues, a lot of them were affected by this, or the building, the outside of the building, because the acid would actually start melting the limestone, which is why the statue no longer has a face. I'm going to just kind of pass over this because, like I said, we've pretty much solved the issue. Okay, how do we mitigate air pollution? First one is we alter human activity. We ask you to drive better cars. We ask you to limit your reliance on electricity. Therefore, we don't have the generating plants that are burning the fossil fuels. We use lower sulfur fuels. So we're going to pay a little bit more at the pump so that our gas doesn't have as many emissions. We're going to regulate emissions. We're going to put money to it. So if you pollute too much, you're going to get fined. And then we're going to go in and try and restore areas that were damaged. If your lake is too acidic, we're going to add a basic solution to it to kind of bring the level back. 1970s, forests were dying, buildings were being weathered. By 1995, the U.S. signed the Clean Air Act that reduced sulfur dioxide. And by 1998, we were still seeing a lot of it in our cars, but not so much in our factories. That's it. Stick a fork in it. Guys, at this time, I want to